Hello guys, I hope you are all doing well. In the previous lecture, we have discussed about introduction to metal casting. In this lecture, we are going to discuss metal casting process. Metal casting processes include sand casting, other expandable mold casting processes, permanent mold casting process, foundry practice, casting quality, metal for castings, and product design considerations. Basically, there are two categories of metal casting processes. First are expandable mold process. Mold is sacrificed to remove part. What is meant by this? It is meant that when we when the molten metal is poured into the mold, it is when it becomes solidified. Then for the extraction of part, we must have to break the mold because it is a sand mold. So there are some advantages. More complex shapes are possible. Disadvantages are production rate may be limited due to there is some time required for the mold creation. Other are permanent mold process. Mold is made of metals and ceramics different and can be used to make many castings. Advantages are high production rate. Disadvantages are geometry is limited by need to open mold because intricate geometries are not made in permanent mold. A little bit overview of sand casting. Most widely used casting process in the world, accounting for significant majority of total tonnage cast. Majority of the casting is done by sand casting. And parts ranging in size from small to very large. In casting, we can create a very small part to a very large part. Production quantities from 1 to millions. We can make a one part and maybe millions. This is a large sand casting, a weight of 680 kilograms. In other words, 1500 pounds for an air compressor frame. Some steps in sand casting. The two halves are mold, clamp together, pour metal into the sand mold, allow metal to solidify, break up the mold, clean and inspect the casting, heat treatment. Sometimes required, but sometimes not. This process is basically we discussed this in detail. Making the sand mold. I have told this in previous same pattern, a full size model of the part, slightly enlarged. I have told this before in the previous lecture. You can watch if you don't see that video. I will give link in description. You can see or visit my channel for getting this. These are some types of pattern. The pattern, this is basically a simple pattern. This is plate pattern. This is plate pattern. This is riser pattern, cope pattern, and gating system, etc. Core. As I have told you before, that core is a thing that is used for making hollow shape or uh, some shape where the metal is not required. Just for example, in this central part, we don't need metal to flow, so we place a core here. It is inserted into mold cavity. The molten metal flows to solidify between mold cavity and core to form casting external and internal surface. May require supports. Sometimes it is acting like a cantilever beam, a long cantilever beam that may be replaced from its actual place. So we use supports to handle it. These supports are basically called chaplets. Foundry sands. The sand we use in the foundry is silica, SiO2, or silica mixed with other minerals. This must have good reflective properties, capacity to endure high temperatures, small grain size to make the finishing better. Also, large grain size sometimes is more permeable to allow escape of gases during pouring. Irregular grain shape tend to strengthen mold to interlocking compared round grain. Disadvantages include interlocking tends to reduce permeability. Binders used with foundry sands. To make the sand sticky with each other, we used a kind of adhesive that is known as binder. The grain of sands are held together by a mixture of water and a bonding clay. The grain of sands are held together by a mixture of water and bonding clay, typically mixed 90% sand, 3% water, and 7% clay. This may be varied according to your use, according to our application. Other bonding agents also used in sand molds. Organic resins, for example, phenolic resins, inorganic binders. Organic resins include phenolic resins, inorganic binders include sodium silicate and phosphate, etc. Additives are sometimes combined with the mixture to enhance strength and permeability. Such example in coal. Several methods, manual and mechanized, are used to compact sand in flask. There are different methods such as hammering process, hammering-like process. Desirable molds, properties and characteristics. How our mold, how we make our mold, what properties we need in the mold. We need the mold to strength, to maintain shape and resist erosion caused by the flow of the molten metal. Also, we need permeability to allow hot air and gases to pass through the voids in the sand. Thermal stability to resist cracking and contact with. Collapsibility, the ability to give way and allow casting to shrink without cracking the casting. It also refers to the ability to remove sand from casting during cleaning. Reusability, can the sand from the broken mold be reused to make other molds? This factor is also be considered for the future molding process. Type of sand molds. There are different type of sand molds. Green sand mold, mixture of sand, clay, water. Green means mold contains moisture at the time of pouring. Most widely used due to low cost, good properties, but moisture can cause problem in some cases. It is basically used major cases. Dry sand mold, organic binders rather than clay, and mold is baked in large oven to improve strength. More expensive and longer production time. It needs it. These molds are expensive and longer production time. This is used for longer time. Skin dried mold, drying mold cavity surface of a green sand mold to a depth of 10 to 25 millimeters using torch and basically in this we dry or provide heat to the mold, sand mold. Buoyancy in the sand casting operation. This is an interesting concept. When we pour during pouring, buoyancy of the molten metal tend to displace the core. When we put metal in the core, when we put metal in the core, it lifts the core upward, just like this. When we pour the metal from here, this when metal from here, it apply by buoyant force to lift upside. Here's the supports, but if there is no supports, it lift it. Core displays can cause casting to be defective. This is also defective and can cause defection. Forces tend to lift the core is equal to weight of displaced liquid less the weight of core itself. Fb is equal to Wm minus Wc, where Fb is buoyancy force, Wm is equal to weight of molten metal. Subtract the weight of the core. So this is basically the buoyant force. This is a small example. You can do it by yourself. If you have any complexity, you can tell me. I will tell you. There are some other expandable mold casting processes, which includes shell molding, vacuum molding, expanded polystyrene process, investment casting, plaster mold, and ceramic mold casting. Shell molding. In the shell molding casting process, in which the mold is a thin shell, approximately the thickness of the shell is 9 millimeter of sand, uh, in thin shell of sand held together by thermosetting resin binder. It is developed in Germany during early 1940s. Steps in shell molding. In the first step, a match plate or a cope and drag, we can use any of them. Metal pattern is heated and placed over the box. This is the pattern, a metallic pattern that is heated and placed over the box, containing sand mixed with thermosetting resin, and also we put the sand with the resin. In the next step, we will invert the drag, the box, scope and drag, and maybe it's a box. The sand will come on the heated pattern, and we will reposition the box. Then some of the sand will fall down, and there a shape of the pattern is formed. Then we put the sand shell in the heated oven, and shell mold is then stripped out from the pattern. So we will get the pattern. the mold. Similarly, we make other one and combine it with the help of sands, and finally pour the metal in it, and we will get the final desired shape. Advantages of shell molding includes smoother cavity, surface permits easier flow of molten metal, and better surface finishing on casting. Good dimensional accuracy, machining often not required in it. Mold collapsibility usually avoid cracks in casting, can be mechanized for mass production. It can also be used for the mass production. That is very big advantage of it. But also it has some disadvantages because it is expensive processes, because metal pattern is required and difficult to justify it for small quantities. For the small production, for example, one or two parts, it is expensive, very expensive. This process is utilized in the manufacturing of gears, valve bodies, bushings, and camshafts, etc. Expandable polystyrene process, use of a mold of sand packed around a polystyrene foam and vaporize the molten metal. Other names are lost foam process, lost pattern process, evaporate foam process, and full mold process. Polystyrene foam pattern includes sprue, risers, gating system, and internal cores if needed. Mold does not have open into cope or drag sections. Pattern can be cut into a foam from one kind, casting or mold for large production runs. You can more clear from here. There is a cup or sprue of foam. Okay, this is a first. We will spray a refractory compound on it, all over it. Then foam pattern is placed into the mold box and sand is compacted around the wall. We put it in the box, put the sand around it, and compact it. Then we put the molten metal, and it will melt the foam placed here and evaporate it outside. In this way, we get the required shape. Advantages: pattern need not to be removed. We don't need to remove the pattern. Simplifies and expedites mold making. The mold making is too much easy. Disadvantages include new pattern is needed for every casting. We must need for another mold, another pattern for other process. Economic justification of the process is highly dependent on cost and producing patterns, so it is also inexpensive. Examples include mass production of casting for automobile engines. Automobiles engines required this process. Automated and integrated manufacturing systems are used to mold the polystyrene foam patterns and then feed them to downstream casting process. This is the process named investment casting or lost wax process. In this process, the pattern is made up of wax coated with refractory material to make a mold, after which the wax is melted away prior to molten metal. Investment come from the one of the less familiar definition of invest, to cover completely, which refer to the coating of refractory material around the wax pattern. Basically, invest means to cover completely, so we completely cover the wax with the refractory material. It is a precision casting process. It has high accuracy, high precision. A separate pattern must be made for every casting. This is also the same as above. Steps in investment casting. First, we have to make the pattern of wax. These are the wax sprue and also the wax sprue. Then we put it in the refractory material by dipping it in it. Then we will heat it and invert it, so the wax is melted out into some cup or some of the thing. Then this is the desired mold. We put the metal in it, and it will go here, and all the and anywhere where we want. Then this is the desired shape. These are basically the cups. Advantages: part of great complexity and intricacy can be cast. Dimensional control: wax can be usually be recovered for reuse. Additional machining are not required. Disadvantages: the process is lengthy, relatively expensive process. Examples are complex machinery parts and blades and other components of turbine engines, jewelry, and dental fixtures. So it is also of big use. This is a part that is made by investment casting. Permanent mold casting processes. This is economic disadvantage. The economic disadvantages of expandable mold casting. A new mold is required for every casting. So to overcome this problem, we use permanent mold casting. The mold is reused many times. The process include basic permanent mold casting, die casting, centrifugal casting. Basic permanent mold is used metal mold construct two sections. There are two sections designed for easy precise opening. Cavity and the getting system include machine is machined into two halves. Basically, there are two halves like pop and drag with the high accuracy in dimensions. Mold for use for lower melting points alloy, including aluminium, magnesium, and copper-based alloys. Mold used for casting steel must be made of refractive material due to very high pouring temperatures. These are some requirements. The steps in the permanent mold casting process are first of all, we preheated and coat with some material. Core are placed if there is some hollow shape required. Put the metal all around it. Remove the force, and this is the desired part. You see this part in the wheels of vehicles. Advantages and limitations of permanent mold casting. Advantages are dimensional accuracy, dimensional control, surface finish, more rapid solidification, and finer grain structure, so stronger casting or strong casting are produced. Some limitation also lies in it, generally limited to metal of lower melting points. Sorry. Simple parts geometries compared to sand casting because of need to open the mold, high cost of mold. Because it is metallic mold, so it also have some cost. Applications of permanent mold casting are due to high mold cost. The process is best suited to high volume production and can be automated accordingly. Uses for high production. Parts made from are automotive pistons, pump bodies, and certain casting for aircraft and missiles. Metal commonly cast aluminium and magnesium, copper-based alloys, and cast iron should be cast in it. Variation of basic permanent molds are slash casting, low pressure casting, and vacuum permanent mold castings. So next is die casting, a permanent mold casting process in which molten metal is injected into mold cavity under high pressure. Typically pressure ranges is from 7 to 350 megapascal. Pressure is maintained about during solidification, then mold is opened and part is removed. Mold in the casting operation are known as dies, hence the name is die casting. Due to use of high pressure, force metal into die cavity will distinguish from other permanent mold process. So this is basically the die casting machine, two main types, hot chamber machine and cold chamber machine. This is basically the movable die. This is short cylinder from where the metal comes and all the things. This is the moving plate that apply force on it. Hot chamber die casting include metal is melted into container attached to the machine and a piston injects liquid metal under high pressure into the die. 500 parts per hour is the production rate. Typically range pressure is 7 to 35 MPa. Casting metals include zinc, tin, lead, etc. This is the hot chamber casting. This is the pot. This is the chamber. Pressure is applied on it. Plunger. This is the plunger, and metal is going to here in the die. This is the die, and this is the final geometry that we get from this process. Cold chamber die casting. You can see it from here. With the die closed and ram withdrawn, molten metal is poured into the chamber. This is the plunger, and the metal is go to the here. And ram is withdrawn, and this is the required part. Mold for die casting, usually made of tool steel, mold steel, or maraging steel. Tungsten and molybdenum metal dies. These are good refractive qualities, so used for die casting. Ejector spin required to remove part from die when it is opens. Just as you see here, there are some pins, and you cannot see here because there are no pins. You can see in further. Lubricants must be sprayed in the cavity to prevent sticking. Venting holes are produced in the dies. Flash is also produced. That is trimmed after this process. Advantages and limitation of die castings are advantages are good for large production, good dimensional accuracy, thin sections are also possible, rapid cooling, but disadvantages are these are limited to low metal points, the metals with low melting points. This is not metal melting points. Part geometry must allow removal from die cavity. Centrifugal casting, as it is clear from the name centrifugal, there is a rotatory or circular motion. So this group includes true centrifugal casting, semi-centrifugal casting, and centrifugal casting. True centrifugal. Molten metal is poured into the rotating mold to produce a tubular part. In some operation mode, rotation commences after pouring rather than before. Parts include pipes, tubes, bushings, and rings. Outside shape of casting may be round, octagonal, hexagonal, but inside shape is perfectly round due to radially symmetric forces. Orientation of the axis of mold rotation can either be horizontal or vertical. In this, internal shape must be round. So this is the true centrifugal casting. In semi-centrifugal casting, this is kind of die. When we pour the metal in it, rotate the die, so half material come here due to centrifugal force, half come here due to centrifugal force. Molds are designed with the riser at the center to supply feed metal. Density of the metal in final casting is greater in outer section due to centrifugal force, often used in parts which center of casting is machined away, thus eliminating the portion where quality is lowest. Examples are wheels and pulleys. Centrifuge casting includes the mold is designed with part cavities located away from the axis of rotation, so that molten metal poured into mold is distributed to these cavities by centrifugal force. Used for smaller parts, radial symmetry of part not required as in other centrifugal casting methods. Basically, in above case, this is same part on both sides, but in this case, these two are separate parts of same symmetry. Furnaces for casting process, heating and melting of metal is accomplished in a furnace. Furnaces are basically of these types: cupolas, direct fuel fired furnace, crucible furnace, electric arc furnace, and induction furnace. This is a cupola, vertical cylinder furnace equipped with tapping spout near base. Used only for cast irons, and although other furnaces are also used, largest tonnage of cast iron is melted in cupolas. The charge, that is molten metal, consists of iron, coke, that is fuel flux, and possible alloying elements, that is loading in the charge door located less than halfway up height of cupola. This is the tapping spout. This is bought for moving metal. This is basically the wind box. This is the charge. This is basically blower to blow the air. And this is the whole assembly. You can see it on the Google or any other place. This is not the task of manufacturing process. Direct fuel fired furnace are small open hearth in which charge is heated by natural gas. Furnace roof assists heating action by reflecting flame down against charge. Air bottom of hearth is tap hole to release molten metal, generally used for non-ferrous metal. It is not of so much use. Crucible is important. Metal is melted without indirect fuel fire furnace. Container, also called, but majorly called crucible, is made of refractory material or high temperature steel alloy. Used for non-ferrous metals such as bronze, brass, and alloy of zinc and aluminium. Three types used in foundries: lift-out types, stationary type, and tilting type. This is the lift-out crucible that is removed, and the crucible is removed. Other one is stationary pot. The pot is stationary. We will take the metal with some spoon or any other thing such as ladle. The term here, not spoon, is ladle. And also the tilting pot furnace. This is the tilting pot. From this wheel we can rotate it and put the metal from, this is the pouring spout. Electric arc furnace, this is the charge is melted with the heat generated from the electric arc. This is some electrodes, and this is an electrical process. Induction furnace is also use alternating current to pass through the coil and develop magnetic field. This is also used in induction hardening of the gears. Electromagnetic force field also cause mixing action in the liquid metal. Since metal does not contact heating element, the environment can be closely controlled, which results in molten metal high quality and purity. This is of good use. This is basically the process. Copper induction coils, refractive materials, molten, and arrows indicate the mixing action. This is like the, because this is the induced current. Moving molten metal from melting furnace to the mold is sometimes done using crucibles. More often transfer accomplished by ladders. This is known as the ladle. Crane ladle. This is basically crane ladle, and this is two-man ladle. Additional step after solidification includes Additional steps after solidification include trimming, removing the core, surface cleaning, inspection, repairing if required, and also heat treatment. Trimming includes removal of sprues, runners, slices that are some extra material, flashes, fins, chaplets. These removal of all the extra things is known as trimming. For brittle casting alloys, when cross sections are relatively small, these appendages can be broken off. For brittle material, this can be brittle after suddenly after the solidification by the use of some hitting material like hammers. Otherwise, hammering, shearing, hacksawing, band sawing, abrasive wheel cutting, and all the grinding methods are used. Removing the core. If core have been used, then must be removed. Most cores are bonded and they often fall out casting as the binder deteriorates. But in some cases, they are removed by shaking the cast, just like this, and other manually or mechanically. In rare cases, cores are removed by chemically dissolving bonding agents if it is very strict. Solid cores must be hammered and passed out. This is very important part. Then surface cleaning is the removal of sand from the casting surface and to enhance appearance of surface. Cleaning methods just like tumbling, air blasting with coarse sand grits, metal shot, wire brushing, buffing, and chemical pickling, etc. You can see the videos and shorts in the YouTube or any other social media platform. Surface cleaning is most important for sand casting, where in my permanent mold process this step can be avoided. Defects are possible in casting and inspection is needed to detect their presence. This is very important. Heat treatment, as we all know, to enhance some properties, we use heat treatment cast. Reason for heat treating a cast for subsequent processing operations such as machining to bring out the desired properties for the application. Casting quality, casting defects. There are some casting quality. There are numerous opportunities for things to go wrong in casting operation. There is possibility of going wrong, resulting quality defects in the products. The defects can be classified as follows. Defects common to all casting process, defects related to sand casting process. First, we discuss the defects common to all casting process. These defects include misruns, cold shorts, shrinkage cavity, microporosity, hot tearing, and hot cracking. Misrun, when the metal is not completely traveled, then this is and solidified before reaching complete filling, then this is known as misrun. I am telling you in simple words, you can read it here. Cold shut, when this is the core, when the metal is traveling around the core and not completely filled, this is the empty space is known as cold shut. Cold shot, when we pour the metal and there is with the high speed, then these bubble like structures are produced in it. This is known as cold shots. Shrinkage cavity, after the metal is solidified, shrinkage occur and these cavities are made. Microporosity, microporosity is the basically small level of a small level of process and porous and bubbles, pores and bubbles. The size is exaggerated here. This is not actually, these are so much small. And hot tearing is basically the just like where the tearing starts from. Defects related to sand castings are sand blow, pinhole, sand wash, scalp, penetration, mold shift, core shift, and mold crack. Sand blow is like the not filling, complete filling. This is basically sand blow. Pinholes are small holes of sand wash is basically when the mold is not so hard, so the sand is rushed into the molten metal. Scab is basically the upward movement of metal. Penetration is also like scab, but this is the metal is going upward. Mold shift, when we cope and drag are not placed fixed, so there is this disturbance. Core shift is lifting core upward, and mold crack is like this. So core shift, when the core is lifted upward from its actual position by pouring the metal, then it is known as core shift. And when the mold is a crack is created in the mold, then the metal is going here. This is known as mold crack. Foundry inspection method include visual inspection to detect obvious defects such as misaligned sculpture and several defects, so several surface flaws. Dimensional measures to ensure that tolerances have been met. And metallurgical, chemical, physical, and other tests include and concern quality of cast metals, including pressure testing to find the leaks, radiographic methods, magnetic MPTs, magnetic particle tests, ultrasonic tests, and mechanical tests are done for this process. So from here, the from here, it is completed. Uh, till now, I hope you are doing so good. If you have any queries, you can comment me. I will clear all your queries. If you have any, then put it in comments. I hope you are getting my points. This is I am doing for the betterment of both for you and for your studies. So till then, we'll see you in the next chapter. This is complete chapter. Next chapter is chapter number 18. So good luck for the next chapter. I want to see you all in the next chapter. Take care.